more about frequency. So frequency can be defined as the rate of change with respect to time. Okay. Change in a short span of time means high frequency. Change over a long span of time means low frequency. Okay, let's look at these two figures. Okay, change in a short span means high frequency. Okay, for example, this one. This means change in a short span. Maksudnya dalam jangka masa yang singkat tu dia ada banyak cycles. Okay. So, this signal with a frequency of 12 Hz. So, this signal has 12 cycles within 1 second. So, the frequency is 12 Hz. Okay. You can see from the graph amplitude versus time. Okay, compared to the next, the one below it. Okay, this one, amplitude, also amplitude versus time. Okay, so this signal has a long span. Okay, change over a long span of time. So dia punya cycle is less than the above one. Okay, so this signal has only 6 cycles. Okay, 1, 2, 3, 4, 5, 6 cycles within 1 second. So that's mean frequency is less than the above one. Okay, the frequency of the second graph of this graph is 6 Hz only. Okay. Okay. Next, if a signal does not change at all, it never completes a cycle, its frequency is 0 Hz. Okay, kalau signal tu langsung tidak berubah, okay, contohnya garis lurus macam ni, frekuensi dia adalah 0. Okay. Okay, if a signal does not change at all, it never completes a cycle, its frequency is 0. Tu kalau signal tu dia hanya garis lurus straight, dia macam mesin jangka hayat di hospital tu straight, dia maksudnya frekuensi dia kosong. Okay, straight secara horizontal. Okay, if a signal change instantaneously, it jumps from one level to another in no time. Okay, ni kalau dia straight, vertically, straight ke atas, frekuensi dia adalah infinite. Okay. Okay, next, let's look at about phase. Okay, what is phase? Phase describes the position of the waveform relative to time zero. If we think of the wave as something that can be shifted backward or forward along the time axis, phase describes the amount of that shift. Okay, so kalau kita bayangkan wave tu, signal tu boleh ditarik ataupun didorong ke depan ataupun ke belakang. Okay, phase tu adalah bermaksud berapa banyak kita shift ataupun tarik signal tu ke depan ataupun ke belakang. Okay, so let's see this figure. Okay, phase is measured in degrees or radian. So kalau amplitude dalam volts, kalau frekuensi dalam hertz ataupun cycles per second. Okay, kalau period, second. Kalau phase can be measured in degrees or radian. Ada dua unit, sama ada dia diberi dalam bentuk degree ataupun radian. Okay, so let's consider this one. A, if the signal start from here, kalau dia bermula, signal tu bermula daripada titik kosong, maksudnya amplitude kosong, time kosong. Okay, phase dia adalah 0 degree. Okay, kalau wave tu bermula di puncak macam ni, okay. So maksudnya, okay, kalau you ingat gambar yang previously I show to you, satu cycle adalah daripada sini ke sini. Okay, ni maksudnya complete satu cycle. Dan kalau 1/4 cycle berada di sebelah negatif, maksudnya macam ni. Okay. Maksudnya dia punya phase is 90 degree. And if the drawing start from here, maksudnya kalau kita lukis daripada bawah ni, setengah cycle berada di sebelah negatif. dia punya phase adalah 180 degree. Okay, 180 degree. Okay. So 360 degree equal to 2 pi radian. Okay. So let's see some calculation here. A sine wave is offset 1/6 of a cycle with respect to time 0. Maksudnya soalan ni dia beritahu kita 1/6 daripada cycle tu sudah pun di shift ke sebelah negative axis. Okay. Okay, macam contoh gambar tadi, 1/4 berada di sebelah negatif ni. Okay. Yang garis putus-putus ni sebelah negative side of time axis. Okay. So, what is its phase in degrees and radians? So, we know that from the equation just now, 360 degree equal to 2 pi radian. Ini adalah formula yang you perlu tahu. Okay. 360 degree equal to 2 pi radian. So, one complete cycle equal to 360 degrees. So, when it mentioned 1/6 of 360 degree, you have to multiply, okay, to know the values in the value in degrees. So, you just multiply 1/6 multiplied by 360 degree. So, you will get 60 degrees. Okay. Next, since the question also asks the value in radian, you have to work on the previous formula. Okay, let me show you the calculation. Let's do it together. Okay. So we know that 360 degree equal to 2 pi radian. Okay. So the question is 1/6 of 360 degree. So already calculated and got the answer 60 degree. Okay. So yang ni we want to know the answer in radian. Okay, so what can you do? Yang ni basic mathematics je. So katalah saya letak sini nilai X. Okay, so X. Dan saya buat darab silang. Okay. Okay. So saya letak. Okay, I put darab silang X darab dengan 360 degree equal to 2 pi darab dengan 60 degree. So, I want to know X. So, 2 pi times 60 over 360. Okay. So, you can use your calculator. Okay. This one. Okay. So, equal to 2 pi 3.142 divide by 6. Okay, divide by 6. So, the answer is 1.04. Okay. 1.046 radian. Okay. So, that's how you get the answer. Okay, next. Okay, this one done. Oh, not yet. Okay, sorry. Let me check first. Okay, this one after this. Okay, next we try to see time and frequency domains. Okay, sine wave shown previously are in time domain plot. So time domain plot means the graph of amplitude versus time. Okay, time domain plot ni bermaksud graph amplitude melawan masa. So the time domain plot shows changes in signal amplitude with respect to time. It is amplitude versus time plot. Another domain plot is frequency domain plot. Is used to show the relationship between amplitude and frequency. Okay, so the graph is peak amplitude with respect to frequency. So for analog signal, it is best represented in the frequency domain. Okay, let's see this one. Okay, so this is time domain. On your left is the time domain. On your right is the frequency domain. Okay, so let's consider this one. Okay, sebelah kiri ni amplitude melawan masa. Sebelah kanan amplitude melawan frekuensi. Okay, waktu saya crop ni dia hilang ni amplitude ni. Okay, so sebenarnya ni adalah graf amplitude melawan masa, amplitude melawan frekuensi. Okay, so let's consider this one. Okay, first yang atas ni, okay, amplitude 5, okay, frekuensi kosong. Why? As I said, kalau if that signal doesn't change at all, okay, meaning that it shows horizontal straight line, okay, it means its frequency is 0. So how to represent it using frequency domain? So cara untuk kita represent dia secara frequency domain ialah amplitude melawan frekuensi. Frekuensi kosong, amplitude 5. Okay, dan ini adalah time domain. The second one, okay, this one how many frequency? 2, 3, 4, 5, 6, 7, 8. Okay, within 1 second. Make sure kalau dalam exam, you tengok masa yang diberi ni kadang-kadang dia tricky sikit, dia tak bagi 1 saat. So, you must be careful here. Untuk pengiraan frekuensi, please make sure anak panah ni, masa yang diberi adalah 1 saat. Sebab pengiraan frekuensi ataupun definition frekuensi is based on 1 second. How many cycles in 1 second? So, we have 8 cycles in 1 second. So, we can represent it using frequency domain 8. Okay, the frequency is 8. Okay, the height is 5. So, just one straight line. Okay. And then for this one, frequency is 16. If you calculate, we have 16 cycles within 1 second. So, frequency 16. Okay, you drag the line straight. Okay, and the height is 5. Amplitude melawan frequency. So as you can see, for analog signal, it is best represented in frequency domain. Why? Very easy to draw compared to sine wave. Okay, this one we have done. Okay, next we come to the term frequency spectrum. What is frequency spectrum? Frequency spectrum of composite signal, description of a signal using the frequency domain containing all its component. So kalau signal tu adalah composite signal, dia akan ada banyak cacat-cacat macam ni lah. Okay, bergantung kepada frekuensi. Okay, we will see later in our exercise. Okay, so ini adalah frequency spectrum.